Hello, this is problem set number 5, problem 1. Four identical charges, Q, are placed at the corners of a square of side L. Part A in a free body diagram show all of the forces that act on one of the charges. Part B, find the magnitude and direction of the total force exerted on one charge by the other three charges. So I drew the four identical charges Q that are at the corners of a square of side L. Okay? So I'm going to label these. So this is charge number 1, charge number 2, charge number 3, and charge number 4. All right? I will also say that the distance between, so this is a 90-degree angle right here, right? Because it's a square. So the angle between this line right here, if this was the distance between point 2 and charge 2 and charge 4, this would be 45 degrees, right? Okay, and if that is 45, 45, and 90 degrees, then the length of this diagonal line, or the distance between charge 2 and charge 4, is the square root of L squared plus L squared, right? Because this is the Pythagorean theorem, c squared is equal to a squared plus b squared. Okay, part A. Draw a free body diagram showing all of the forces that act on one of the charges. So I'm going to choose to show all the forces acting on charge number 4 right here, okay? You don't need to choose the same. If you want to choose the charge or the forces acting on charge number 2 or charge number 3, that's fine. I just want to show the one on charge number 4. Okay. So part A, I'll draw a free body diagram, right? So this is my y, positive y, and this is my positive x, okay? And here I have my charge number 4 with a charge of Q. And I will use, I guess I'll use this mustard color to show my forces. Actually, I'll use green to show my forces. Okay. All right, so the first force that I'll experience is the force acting from charge number 1, right? That guy. So I will experience this guy, which is F1. That's the force coming from charge number 1 right here, acting on charge number 4, right? Okay. My second charge from charge number 2 would come at this angle at 45 degrees, right? So it would come at this angle. This is my F2, force coming from charge number 2. And then I would also feel a force coming from charge number 3, coming this way. So F3. Okay. So those are the three charges, or those are the forces that act on charge number 4, which is this charge right here. Okay. All right. Part B, find the magnitude and direction of the total force exerted on one charge by the other three charges. Okay. So for part B, I can do that. I can simplify things actually by taking this guy I will copy that and paste. But I am going to rotate it. I will rotate it this way. Okay. And the reason I rotated it was so that I could cancel out some of my forces. So if you notice here in part A, I wouldn't have any forces canceling out, right? Because I have F1 going in the positive Y. Oops, this was supposed to be F3. Okay, and then I would have F2 coming in at an angle right here at 45 degrees. So if it's coming that way, I would experience an F2 at the positive Y, and I would also experience an F2 coming towards negative X, right? Then I also have to add the F3 also going towards negative X. So nothing would cancel out if I leave my orientation the way I drew it right here. So a little tip for that to cancel things out is I reorientated my drawing. I tilted it by 45 degrees, right? And by doing so, I will at least now get my forces, right? Because this time I'm going to have a force from charge 3, an F3Y coming down, and a charge or a force from charge 1 coming up, F1Y. And those guys will cancel out, right? Because they both have a distance of L and a charge of Q. So I did, that's a little trick just to simplify things for me, but you didn't need to do that. If you wanted to not cancel things out and stay in this orientation, that's totally fine as well. But as a reminder that we can manipulate our orientation to cancel things out due to symmetry, I'm gonna tilt it 45 degrees, all right? Okay. So I am looking for F, my total force, as a vector, which means magnitude and direction, right? Side note, right? If you guys don't have this in your cheat sheet, you should. But the magnitude of an electric force is equal to KQ1 times Q2 over R squared. Okay? And the value of that is also this is Coulomb's law, right? And you guys should have this in your cheat sheet. So K is the electrostatic constant. So it is a constant, right? And also K is only equal to what is K? 1 over 4 pi times epsilon naught. So this is a constant. Okay, also have this in your cheat sheet. So we could substitute K here, or yeah, the letter K. So this would be equal to Q1 times Q2 over 4 pi epsilon naught R squared, okay? That is also the magnitude of electric force. This is a Coulomb's law. Okay. And E naught is the permittivity of free space, which just means this is how well the electric field works in a vacuum, okay? And R squared, that is the distance between the center of charges. Okay. All right, moving on. So I want to find the magnitude first of charge 1, or the force 1 and force 3. And the reason for that is because they are equal. The magnitude of force 1 is equal to the magnitude of force 3 because we have the same distance between the center of the charges, right? It's distance L for both of them. Also, we have the same charge for every point, so we have charge Q here, and charge Q here. So they will be equal based on this formula, right? K is a constant, Q1 is Q, capital Q, Q2 is capital Q, and R2 is just L squared. R squared is just L squared, right? Because that's the distance between our charges. Okay, so that would be equal to K Q1 Q2 over R squared, which in this case is equal to K Q times Q over L squared. And I'm going to just call this Q squared. All right, so that is the value of my magnitude for force 1 and the value of my magnitude for force 3. All right, so I'm going to put a square around that so I know that I will need that later. What about my magnitude for force 2? Okay, well, K is just a constant, so I will write that down, right? What about Q1 and Q2? They're still just both big Q's, right? Because, again, in the problem, 4 identical charges of capital Q. So everything in this problem is just Q1 is capital Q and Q2 is also capital Q. Therefore, we have Q squared. Capital Q squared, okay? What about my distance between charges? So the only 2 points with different distances between the charges is the distance from charge 2 to charge 4, right? That's a diagonal of the circle, or a square root of, if each side of the square has a side of length L, then that is the square root of 2L squared. And then we square the whole thing, right? Because it's R squared. So the magnitude of force 2 is K times Q squared over 2L squared, okay? So now I know the magnitudes of the forces acting on charge 4. Now let's find the vector for them, okay? So these are the magnitudes, right? All right. Now the vector will be, actually I'll write this down here. So for vector of force 1, right? That's the force acting on charge 4 from charge 1, okay? That's this guy. That will be equal to, again, remember this is 45 degrees right here, right? And then we are experiencing a force coming this way, right? We call that F1. A force coming this way, we call that F2. And a force coming this way, which we call, that's F3, okay? So for force 1, that would be equal to, if we imagine this is a 90-degree angle, so that's a triangle, F1 and along the x direction, okay, this is my coordinate system, x and y. So along the x direction, I would get negative, right? Because it's pointing, F1 is pointing towards negative x. Its x component is pointing towards the negative x direction. So minus the magnitude of F1 cosine of 45. So that would be the x component of F1 in the I hat direction, right? And then plus for F1 right here, its y component is pointing towards positive y. It's pointing up, right, towards positive y. So plus positive magnitude of F1 sine of 45, right? And that's in the j hat direction. What about F2? And if you guys are wondering where the cosine 45 and sine 45 is coming from, I guess I should quickly clarify. I'll use pink to clarify. So I had an F1 coming this way, right? That was felt onto this. That was what was felt by charge 4 right here, right? That was charge 4. That was a 90-degree angle. This was 45 degrees. Okay. So, and if this was my x and y coordinate, then this guy right here, I'll change the color to brown. This guy right here, this would be F1 sine of 45. That's my y component of F1, right? And then this guy right here would be pointing towards negative x direction. And that's my x component of F1. That would be F1 cosine of 45 degrees. So that is my x component of F1. Yeah? So that's just to clarify the cosine 45 and sine 45s that you guys are seeing. Okay, I'm going to erase that now. All right, so for F2, you can see that this is a horizontal force, so it only acts on the x direction, and it doesn't have any component in the y direction, right? So we will have a negative magnitude of force 2 in the I hat direction, or along x. And then we don't have any component of force 2 in the y direction, so that's 0 j hat plus 0 j hat. All right. And for force 3, similar to F1, right? Which is actually why we changed the orientation and tilted this by 45 degrees in the first place, because I'm just trying to cancel out the equal and opposite forces in the y component for F1 and F3. All right, so let's start with the x component for F3. Obviously, the x component is also pointing in the negative x direction, or negative I hat. And in the y component for F3, it's pointing down in the negative j hat direction. Okay, so let's write that down. So for F3, we have negative the magnitude of force 3. times cosine 45. Okay. Plus negative the force of, or the magnitude of force 3 sine 45, right? And that's in the j hat direction because it's pointing down. And remember, F1 magnitude is equal to F3 magnitude. So these guys are going to cancel out later, which is perfect. That's what we wanted. That's why we tilted the square 45 degrees. What else? Is there anything else I want to say on this topic? Yeah, so moving on, let's calculate our F total, which is what we were looking for part B, right? So the total force acting on that point 4, or charge 4 right here, is going to be equal to F1 plus F2 plus force 3, right? Force 1 plus force 2 plus force 3 is equal to the total force. So I will first get the forces in the I hat direction and add them together, these guys. Okay? So I will have negative magnitude of force 1 times cosine of 45, okay, minus the magnitude of force 2 minus the magnitude of force 3 cosine 45, all in the I hat direction, okay? Now let's get the values for j hat, or along y, and add them together. So these first ones was our x hat, and now we're going to do y hat, which is plus magnitude of F1 sine 45 minus the magnitude of F3 sine 45 in the j hat direction, right? So now that is this guy right here. That's our y component forces. All right. Notice that, oops, what's going on? Remember F1, the magnitude of F1 is equal to the magnitude of F3, right? That's what we figured out right here, right? So because magnitude of F1 is equal to magnitude of F3, then these guys cancel out, oops, and this just becomes 0, right? So we have no components along j hat, or along the y direction. Okay. And this was canceled out due to symmetry, right? The distance between charge 4 and charge 3 is L. The distance between charge 4 and charge 1 is L. And the y component for F1 is going up, but it's equal in magnitude but opposite in sign to the magnitude, to the y component of force 3, right? So that is what that is about. So now let's just plug in our values for magnitude of F1 and magnitude of F2 and magnitude of F3, right? So here we get magnitude of negative magnitude of F1 again. We found up here to be KQ squared over L squared. So negative KQ squared over L squared. Cosine of 45 is just the square root of 2 over 2. Okay. So that is my first term minus the magnitude of F2, that is kq squared over 2L squared. Okay, that's my second term. And my third term is minus magnitude of F3, which is also kq squared over L squared. And cosine of 45 is square root of 2 over 2. And this is all in the I hat direction, right? So let's multiply this out. Let's distribute the negative. So that's negative square root of 2kq squared over 2L squared minus kq squared over 2L squared minus square root of 2 over 2 times kq squared over L squared. All right, notice all our denominators are the same, so we can group the terms together. We can subtract them together. All right, and we would get that is equal to minus 2 square root of 2 kq squared minus kq squared over 2L squared. Okay. Again, this is all in the I hat direction, or along x, okay? So that is equal to, or I'm gonna factor out the like terms. So I can factor out kq squared over 2L squared. And what I would be left with is minus 2 square root of 2 minus 1, right? Again, that's along I hat. I'm going to bring out the negative sign, okay? So that will be negative kq squared over 2L squared times 2 square root of 2 plus 1. All in the I hat, or x component direction. That is the total forces, F total. That is also our final answer. So we have the magnitude and the direction. Okay, actually, I will also add the j hat just for clarity. So again, j hat is 0, so plus 0 j hat. Okay. And that is our final answer.